Welcome back. Now we will do the laws of motion, same chapter. That is the next topic after we finished first force, its introduction a little bit, its definition, and after that balanced and unbalanced force, and then resultant force and friction also in between, and then now laws of motion. Before doing this laws of motion, I'd like to tell you that earlier it was believed that whenever one object is moving, earlier it was believed that if this object is moving, it will eventually stop because its nature is like that. There is no reason. It was believed that it has to stop. That is true, but why there was no such reason? Then Galileo was the first person who came and told that it is the friction. It is the friction which makes the object stop. After he gave some experiment also, Galileo boldly asserts the exact opposite. He reasoned that moving object eventually stopped due to the force called friction. He was the first one also. And he gave some interesting examples also, like if there is a plane area, like this, if I drop a marble here, it will come and it will go up here. If there is no friction, it is perfectly smooth, and marble is also perfectly smooth, same height it will go and same height it will go. But condition is it has to be perfectly smooth, no friction. Between the marble and the plane, no velocity has to be reduced. So that is his idea. And he said, if I make this plane like this, it will come down and it will go a little more far. It will go far than this. Similarly, if I make this plane like this, we said that the marble will come here and it will never stop. But he gave the condition, no friction. Friction is not there, then it will happen. So after that, many years passed, and then Newton came, Isaac Newton, and he gave all these things in a proper way. That is called laws of motion, Newton's laws of motion. There are 3 Newton's laws of motion: first law, second law, and third law. In these 3 laws, these are the starting points from where Newton also started. In fact, Newton's first law is almost similar to this. It's also called law of friction. So Galileo's idea, we'll see only this much, not much there, and we'll start Newton's first law of motion. You can understand that Galileo was the first one who pointed out scientifically the things, and Newton was the one who made it systematic, proper way of laws. Now how he said is that an object at rest or in uniform motion will remain at rest or in uniform motion unless an unbalanced force acts upon them. Acts upon it, because it means that object. First law says that it is almost like that definition we already did. In the force explanation also we understood all these things. An object, if it is at rest, we said it will remain at rest if I do not apply any force from outside. That is easy to understand. He also says, just like rest, uniform motion is also like that. If you don't disturb, it will remain like that. It will continue to move and move and move. Then why does the object stops after it is? If you kick one ball, it will go after some time, it will stop. You know that. That means what? What is that force which is acting? Unbalanced force. It is the friction which is acting. So Newton says that if that would not have been there, when I kick the ball on the surface, between the ball, if a person is there, he kicked that ball, this is the ground, okay, if he kicked the ball and it is moving, it will continue forever, but it stops. Why? Because he says there is friction here, that is why it stops between the ball and this. Otherwise it would have gone forever. So that is his idea. Okay, so again I'll tell you, Newton's first law is that he said any object will remain at rest. That is easy to understand. If you don't disturb, nothing will happen. Also he said if it a uniform speed, uniform motion, it will also continue to be like that if you do not disturb with any force from outside. This is the first law of motion. Okay, and this first law is also understood with the example of inertia. To understand this, we study one more new topic, what is inertia. It is what? The tendency. Tendency means the way it acts. Tendency of a habit, you can call it habit. The tendency of a body to remain at rest or in uniform motion. Is called inertia. Don't confuse this with friction, okay? Different. Inertia is, every object has inertia. If it is at rest, that inertia of the body will make the body remain there. Because of the inertia, it will stop there. If an object is moving, again that also will have inertia. Inertia of motion. That will tell or make the body remain like that forever, moving like that. So that is called inertia. Okay. Three types are there. Number one, inertia of rest, inertia of motion, and number three, inertia of direction. These three things are there. Inertia of rest will tell the body, don't move, you are at rest. Inertia of motion is going to tell the body, we are in motion, let's not stop. Inertia of the direction will tell, be in the same direction, don't change the direction. So this is the inertia of the body. Okay, that is not living thing. Okay, when I tell it will tell the body, means it will make the body. Okay, not living thing, but it is the inside of every object, inertia. Remember, we are trying to understand first law of motion. First law of motion says that any object will remain at rest or in uniform of motion unless any force acting on it. And inertia is that property of the body which makes the body remain at rest or in uniform motion until something disturbs it from outside. Okay, it is a idea of inertia. Now practical applications are there. There are questions also asked from these applications. What are the practical applications? Means in our day-to-day life where we see these things. Inertia of rest. It is the inherent property of the body by virtue of which means due to which, because of which. Okay, by virtue of which means because of which the body remains at rest unless an external force is applied to it. Now this is inertia of rest. Now examples. Example A is a man while jumping from a moving train or bus falls forward. Okay, let's try to understand it, how it is happening. This happens, falls forward, all important, okay, falls forward, not backward. Suppose there is a train or bus moving this side, a person is here on the door, and when the bus is moving, he is jumping outside. Next situation, what happens? Bus is here, the door is here. When he jumps, he will fall here. Understand? This happens. Okay? If that person is jumping out of the bus or train, any moving object this side, when man while jumping from the moving train falls forward. Why this is happening? We'll try to explain in very detail. It's not difficult to understand. You will be able to write in your own words how it is happening. Okay? And in other examples also you are able to guess it, how it is happening. We only know one thing, that inertia of the rest is there on the object, that is the body of the human. I will zoom his feet, his body, so that you understand how it is acted in his body. Suppose this is this person, feet are important, okay? He is inside that door of the bus. The bus is moving, you know. Okay, this is the door of the bus. He is there, standing there. Now, it is the inherent property of the body by virtue of which the body remains at rest unless an external force is applied to it. Now, you know that when the bus is moving, he is in touch with the bus here. Can you see his touch here? So that means what? His feet are also moving this side. Remember, his feet are also moving. Okay, his legs are in touch with the bus. Bus is moving. Bus is moving. So legs are in touch, also moving, right? Now when he jumps, what will happen? When he jumps, what will happen? When he jumps, what will happen? His body is in motion. Remember, inside the bus, his body is in motion. When he jumps outside the bus, okay, he's no more here. This is the ground, road, okay, road's side of the road. He went up here, and as soon as his feet are in touch with the ground, he falls. What is the reason? Is because when he touches the ground, okay, when he touches the ground, when he jumps, what will happen? On touching the ground, ground it is at rest, right? What will happen? His leg will come to rest, but now comes the important, his remaining part of the body still moving forward, just like the bus. His body is also moving in the front direction, just like the bus, jumping from a bus. Upper part of the body remains in motion. The lower part of the body comes to rest, legs will come to rest, but his remaining part of the body, that means upper part of the body, remaining upper part of the body still moving forward. So what will happen? Your legs are rest, but this upper part is moving. That means moving means forward direction. He will fall, legs will remain here, maximum body will go in the front. This is the reason how it is. Why this is happening? Because the inertia of the body is making him remain in the same state what he was earlier. So this is how you explain the first one. Okay. Examples are there, other examples too.